You lie still and the world feels calm, but the calm is an illusion that soothes rather than deceives. Beneath you, beneath walls and roads and roots, the earth is always moving. Not in a way that demands attention, not in a way that startles. It moves the way your chest moves when you breathe in sleep. Slowly, patiently, without asking to be noticed. You are used to thinking of earthquakes as sudden events. Sharp moments, a before and an after. But the planet does not work in jolts alone. Long before stone breaks, it listens to itself. Pressure accumulates grain by grain. Energy leans, hesitates, redistributes. The earth is restless, but never rushed. As you rest with this idea, science feels less like a spotlight and more like an ear pressed gently to the ground. To study the planet is not to dominate it, but to notice it. To learn its rhythms the way you learn the breathing of someone asleep beside you. You do not interrupt. You simply listen. Beneath your feet, massive plates of rock drift across the planet's surface. They move at the speed your fingernails grow. A few centimeters a year. Too slow for urgency. Too slow for fear. Where these plates meet, they do not slide smoothly. They catch. They resist. They store tension the way a bent branch stores energy. Nothing looks different on the surface. Cities glow. Rivers flow. Life continues unaware. Yet the rocks remember. Every tiny shift leaves a trace. Every added layer of stress changes the balance ever so slightly. The planet keeps careful records, written not in ink, but in gravity, pressure, and time. You begin to imagine Earth not as an object, but as a body, a vast one. Mountains become shoulders. Fault lines resemble old scars. The deep interior hums like a distant heartbeat. This metaphor is not just poetic comfort. It helps you understand something real. Like bodies, planets respond before they react. They signal before they break. For most of human history, those signals were too quiet to hear. We felt the shout, never the whisper. An earthquake arrived without warning, and meaning was assigned afterward. Stories followed shaking, not before. Fear grew in the absence of understanding. But listening is improving. Modern science learns that Earth's movements slightly change the forces around it. When rock compresses, gravity shifts just a little. When mass rearranges deep underground, time itself stretches and tightens in almost invisible ways. These changes are so small they pass unnoticed by everyday instruments. They are drowned out by footsteps, traffic, wind, and weather. Yet atoms notice. Atoms are sensitive in a way nothing else is. They respond to the universe with total honesty. They do not guess. They do not smooth over details. They follow physical laws with perfect obedience. When gravity changes, even by a whisper, atoms feel it. This is where listening becomes extraordinary. Imagine a glass of still water. When the ground tilts slightly, the surface responds instantly, forming a curve so gentle you might miss it. Atoms behave in a similar way, except their surface is probability, and their response is precise beyond imagination. They shift their internal rhythms when forces around them change. They keep time with nature itself. You are not yet thinking about devices or machines. Not yet. You are simply resting with the idea that the universe provides its own sensors. That the smallest pieces of matter may be better listeners than we have ever been. The earth does not hide its intentions. It just speaks softly. Deep underground, before rock fractures, it compresses. It warms. It redistributes weight. These changes slightly alter the pull of gravity in that region. The difference is tiny, far less than you would feel standing on a hill versus a valley. But atoms do not need hills. They notice slopes measured in billions. This realization changes the emotional shape of science. Instead of racing to predict disasters, it begins to cultivate patience. Instead of forcing answers, it learns how to wait. You begin to sense that the future of earthquake detection is not about speed, but about stillness. To listen well, you must reduce noise. The planet is loud in human terms. Machines vibrate, power grids hum. Even the atmosphere presses and releases constantly. All of this motion masks the subtle signals that come before an earthquake. So listening requires isolation, quiet, and trust in delicate things. It requires believing that atoms can tell a story. As you imagine this, your own body becomes part of the metaphor. You know when something is wrong before pain arrives. Tightness, a change in balance, a subtle discomfort that precedes the sharp signal. You may not know exactly what will happen, but you sense that something is building. The Earth experiences its own version of this awareness, and science is learning how to tune in. You begin to understand that earthquakes are not failures of prediction. They are failures of hearing. The information has always been there, folded gently into physical laws. Only now are we learning the language well enough to interpret it. Atoms, when cooled and isolated, behave in ways that amplify sensitivity. Their wave-like nature becomes noticeable. They interfere with themselves, creating patterns that respond exquisitely to external forces. These patterns shift when gravity shifts. They stretch when time stretches. They act as translators between the planet's deep movements and human understanding. But you are not yet deep in equations or instruments. Tonight you stay with the feeling, with the idea that Earth is speaking constantly, and that listening is an act of respect. This changes how fear feels. When danger is sudden, fear is sharp. When danger is gradual and detectable, fear softens into preparation. Knowledge does not erase earthquakes, but it may soften their impact on the human nervous system. It replaces helplessness with awareness. As you breathe, you imagine the planet breathing too. Inhaling pressure, exhaling tension. The cycles take decades, centuries, millennia. Time scales that make human impatience irrelevant. But atoms, small and patient, do not mind waiting. They are always present, always responsive, always honest. You begin to feel that science, at its calmest, is an invitation. An invitation to slow down enough to notice what was always there. To trust that the universe leaves clues. To believe that listening can happen before breaking. The chapter settles into silence now, but the listening continues. Somewhere, atoms are keeping time with gravity, and gravity is shifting ever so slightly. As you drift closer to sleep, a new curiosity forms quietly in your mind. If atoms can listen so carefully, you wonder what else are they already measuring, tick by perfect tick. You begin this chapter by moving inward, not outward. Away from landscapes and fault lines, away from rock and gravity, and towards something unimaginably small. You travel into the quiet interior of matter itself, where time does not rush and nothing ever needs to hurry. Here, deep within the atom, you find clocks. They do not have hands or faces. They do not tick loudly or announce themselves. They keep time by vibrating, by oscillating, by repeating a motion so steady that it becomes the most reliable rhythm humans have ever discovered. These are not clocks built by people. These are clocks built into reality. An atom, when left undisturbed, moves between energy states at a frequency that never changes. It does not drift. It does not grow tired. It does not lose track. Each oscillation is identical to the last, and the next will be identical too. You can imagine it like a breath that never falters, never deepens, never shortens. Perfect patience. Human clocks have always borrowed from nature. We watched the sun. We followed the moon. We counted the swing of pendulums and the vibration of crystals. Each step forward brought more precision, but also more fragility. Gears wear down. Springs weaken. Electronics drift with temperature. Atoms do not. Their rhythm comes from the structure of the universe itself. The forces that bind electrons to nuclei determine their timing. As long as the laws of physics hold, these clocks keep ticking. Quietly, faithfully, without complaint. You let this idea settle. Time, something that often feels abstract and slippery, becomes intimate and tangible. It lives inside matter. It pulses within the smallest building blocks of everything you know. Atomic clocks are already woven into your daily life, even if you never think about them. They guide satellites overhead. They allow GPS to work at all. Without them, navigation would drift by kilometers each day. Time errors would pile up invisibly until location itself became uncertain. But tonight, you are not thinking about directions or devices. You are thinking about listening. Because these clocks do more than measure time. They respond to their surroundings. When gravity changes even slightly, time changes too. This is not metaphor. It is a quiet consequence of relativity. Stronger gravity slows time. Weaker gravity lets it run faster. The difference is tiny, but atomic clocks notice. An atom's ticking rate shifts when gravity shifts. It is as if the clock is gently stretched or compressed by the weight of the planet beneath it. Place the same clock on a mountain and in a valley, and it will disagree with itself. Not by much. Not enough for human senses, but enough for atoms. You begin to feel how this connects to the restless planet beneath your feet. When mass moves underground, gravity changes. When gravity changes, time changes. When time changes, atomic clocks whisper their disagreement. Listening once again becomes possible. Unlike seismic waves that arrive after rock breaks, atomic clocks respond before. They notice the rearrangement of mass that precedes motion, the slow leaning of stress, the subtle redistribution of weight. They are sensitive not to shaking, but to intention. You imagine an atom counting quietly as the earth prepares itself. Tick, tick, each beat steady until something shifts. The rhythm changes by a fraction so small it would take millions of years to feel directly. But instruments designed to listen do not ignore such subtleties. This changes how you think about warning. It is not about predicting the exact moment of rupture. It is about sensing the preparation. Like noticing someone inhaling deeply before speaking. Like hearing the pause before thunder. Atomic clocks do not panic when they detect change. They simply record it. Their calm becomes contagious. Science begins to adopt their temperament. Instead of rushing for certainty, it accepts precision. Instead of dramatic alerts, it works with quiet signals. You rest with this softness. The idea that safety might come not from louder alarms, but from gentler awareness. In laboratories around the world, atoms are cooled to near absolute zero. Their motion slows, their noise fades. In this stillness, their ticking becomes clearer. Scientists trap them with light, suspend them in place, and let them count. The environment is controlled not to dominate the atoms, but to protect their honesty. When you imagine this, it feels almost caring. A shelter built for truth. The clocks themselves are indifferent, but the listening is not. Humans choose to trust these tiny oscillations. They choose to believe that the universe speaks consistently, if only you give it the space to do so. Time, you realize, is not just a backdrop for events. It is an active participant. It bends. It stretches. It responds. And atoms are its most faithful messengers. As the Earth subtly shifts underground, atomic clocks above it feel the difference. They fall out of step with their twins elsewhere. That disagreement is not error. It is information. This is how something so small begins to watch something vast. You picture a network of clocks spread across a landscape. Not ticking loudly, not flashing warnings. Simply counting, comparing, noticing when their shared rhythm slips. From that slip, a map begins to form. A gentle outline of stress, invisible but real. The planet, once again, is speaking softly, and time is the medium of its voice. You notice how comforting this feels. Earthquakes have always been associated with suddenness and fear, but here they become part of a longer story. A story with foreshadowing. A story that can be read if you know where to look. Atoms do not predict disasters. They do not promise safety. They offer something quieter and more honest. They offer notice. As you breathe slowly, your own sense of time begins to soften. Minutes stretch. Thoughts slow. The ticking inside the atom mirrors the rhythm inside your chest. Steady. Reliable. Calm. You realize that listening to atoms is also a lesson in patience. They teach you that meaningful changes are often subtle. That clarity does not arrive with force. That truth can be gentle. The clocks continue counting whether you watch them or not. They do not need attention to function. But when you do pay attention, the universe feels less chaotic. Patterns emerge. Signals become visible. You rest with the thought that time itself may be a sensor. That by measuring it carefully enough, You can feel the movements of the earth before they reach the surface. As sleep draws closer, the ticking fades into the background of your awareness. Not gone, just distant. Somewhere, atoms continue their perfect rhythm, waiting for the next tiny change. And as you drift, another question begins to form, barely louder than a whisper. If atoms can keep time so faithfully, what happens when matter itself starts to blur and overlap, and certainty begins to soften? You drift even deeper now, past clocks and ticking rhythms, into a place where matter no longer feels solid. Here, the rules you learned early in life loosen their grip. Objects are not always where you expect them to be. Motion is not always a straight line. Certainty fades, not into chaos, but into something softer and more forgiving. This is the quantum world. At first, the idea unsettles you. You are used to believing that things are either here or there, moving or still, known or unknown. But atoms do not live by these sharp divisions. They exist in possibilities. They spread. They blur. They behave less like pebbles and more like whispers. An atom at its deepest level is not a point. It is a cloud, a suggestion, a probability that thickens where it is most likely to be found. You cannot say exactly where it is, only where it tends to linger. This is not a flaw in measurement. It is the nature of matter itself. You let this settle gently. The universe, it seems, prefers softness. When atoms move, they do not follow a single path. They explore many paths at once. These paths overlap and interfere, creating patterns that carry information. Like ripples crossing on a pond, they strengthen and weaken one another. From this interplay, meaning emerges. This is what scientists call a wave, but the word hardly captures the feeling. It is more like a breath spreading through space, more like a thought half-formed, present without being pinned down. You begin to understand why this behavior is useful for sensing. A rigid thing resists change. A soft thing responds. When matter behaves like a whisper, it hears whispers too. In the quantum world, small forces leave noticeable traces. A tiny change in gravity shifts the shape of an atomic wave. A slight acceleration alters its phase, like nudging a melody just off-key. These shifts are delicate, but they are consistent. They can be measured, compared, trusted. This is where sensing becomes almost poetic. Instead of measuring impact, quantum sensors measure influence. Instead of waiting for motion, they watch potential. They notice how the environment shapes possibility itself. Nothing needs to break. Nothing needs to shake. The whisper is enough. You imagine atoms drifting through space, their waves overlapping like gauze. When gravity pulls more strongly in one direction, the overlap changes. The pattern shifts. The whisper carries news. This softness once frightened physicists. It felt like uncertainty meant ignorance. But over time, it became clear that uncertainty is not a lack of knowledge. It is a different kind of knowledge. One that accepts the world as fluid rather than fixed. You feel comfort in this. Sleep itself is a quantum-like state. Thoughts overlap. Images blur. Boundaries dissolve. You are not fully awake or fully gone. You exist in between, where meaning is felt rather than defined. Quantum sensors live in this in-between space. To make them work, scientists do not force atoms into rigidity. They encourage their natural softness. They cool them, isolate them, and let their wave-like nature expand. In this state, atoms become exquisitely sensitive to their surroundings. A tiny push changes everything. You picture two identical atoms drifting side by side. They begin together, sharing the same rhythm. As they move, one experiences slightly stronger gravity than the other. Their waves slip out of alignment. The difference grows slowly, predictably. By measuring that difference, information emerges. This is how whispers become messages. The Earth's interior shifts mass long before it shifts rock. These movements alter gravity in subtle ways. Classical instruments struggle to notice, but quantum waves feel the difference immediately. Their softness becomes their strength. You realize that this approach requires trust. Trust in patterns you cannot see directly. Trust in mathematics and metaphor. Trust that reality is consistent even when it is not solid. This trust reshapes fear. When the world feels rigid, breaking feels catastrophic. When the world feels fluid, change feels continuous. Earthquakes stop being surprises and start becoming conclusions. Endpoints of a story already underway. Quantum behavior teaches patience. It teaches you that nothing appears from nothing. Everything emerges from preparation, from buildup, from quiet shifts that precede loud outcomes. You rest with this understanding. The planet, like an atom, lives in probabilities. It explores stress pathways long before choosing one. It leans into many futures at once, until conditions narrow the options. Quantum sensors do not predict which future will happen. They simply notice when the balance changes. This feels honest, humble, safe. You think about how humans often demand certainty. A yes or no, a time and date, but the universe rarely speaks that way. It offers gradients, tendencies, gentle warnings. To listen well, you must accept ambiguity. Atoms are comfortable with ambiguity. They live inside it. As your breathing slows, you imagine yourself becoming wave-like too. Thoughts overlapping, awareness spreading. You are not a point in space, but a field of sensation. Calm spreads outward, touching the edges of sleep. In this state, the idea of sensing feels less technical and more intuitive. Of course, softness detects softness. Of course, whispers hear whispers. The planet does not announce its intentions with force. It hints, it suggests, it shifts probability. Quantum sensors are built to notice these hints. They do not replace traditional instruments. They complement them. They add a layer of awareness that was previously inaccessible. A quiet channel beneath the noise. You imagine this channel humming beneath cities and mountains. Not audible, not visible, just present. A layer of perception woven into the world. Matter behaves like a whisper here, and that whisper carries stories of strain, movement, and time. As the chapter draws toward rest, you feel less concerned with how these sensors are built, and more with what they represent. A willingness to meet the universe on its own terms. To listen gently instead of demanding answers. Softness becomes a virtue. The whisper continues even as you drift. Atoms overlap. Probabilities shift. Somewhere deep below, gravity leaves faint impressions on quantum waves. And as sleep approaches, another subtle curiosity rises. If matter can whisper so clearly, you wonder, how does gravity leave its fingerprints on everything it touches? You rest now with the idea of gravity, not as something dramatic or crushing, but as something intimate. Gravity is with you even when you forget it exists. It holds you to the surface of the planet without effort or sound. It presses gently through your body, through walls, through stone, asking nothing in return. Most of the time, gravity feels constant, predictable, safe. But it is not uniform. It varies from place to place, from moment to moment, shaped by the distribution of mass beneath and around you. Mountains pull slightly harder than plains. Oceans tug differently than deserts. Even buildings, even your own body, leave tiny impressions on the space around them. You do not feel these differences directly. Your senses are not built for such delicacy. But gravity is not subtle in its honesty. It records everything. When mass moves underground, gravity changes. When rock compresses, when fluids shift, when stress redistributes deep within the Earth, the gravitational field above responds. The change is unimaginably small, but it is real. The planet leaves fingerprints everywhere it goes. For a long time, these fingerprints were invisible to us. Traditional instruments could feel shaking and sound, but gravity's whispers slipped past unnoticed. They were too quiet, too smooth, too patient. Quantum sensors changed that. They do not measure gravity as weight. They measure it as influence. They notice how gravity alters motion, time, and probability. They detect how space itself tilts ever so slightly when mass rearranges. You imagine gravity not as a downward arrow, but as a landscape. A gentle slope that curves and shifts depending on what lies beneath. When underground mass gathers, the slope deepens. When mass releases, it relaxes. Nothing breaks. Nothing snaps. The shape simply changes. Atoms feel this immediately. When atoms fall, they follow gravity's contours perfectly. When those contours shift, atomic motion shifts too. Not abruptly, not violently, just enough to be noticed by something sensitive enough to pay attention. You begin to see why gravity is such a powerful messenger. Cannot be blocked, cannot be hidden, passes through everything. Whatever happens underground announces itself gravitationally, whether we are ready to listen or not. This makes gravity an honest storyteller. Before an earthquake, rock deep below bends and strains. Plates push and resist. Density changes. Stress builds. All of this slightly reshapes the gravitational field at the surface. The Earth's posture changes before it moves. Quantum sensors are designed to notice posture. They observe how atoms drift, how waves interfere, how time ticks just a fraction faster or slower. Each observation is a tiny note in a larger composition. Together, they form a picture of gravity's evolving shape. You rest with the thought that the Earth prepares itself long before it releases energy. That preparation leaves marks. Not dramatic ones, but consistent ones. The kind that reward patience. This understanding softens fear again. Earthquakes are not sudden betrayals. They are conclusions. The end of a long negotiation between forces you cannot see. Gravity carries the minutes of that negotiation. You imagine standing on the ground while, far below, stress redistributes itself like a slow tide. The surface remains calm. Birds rest. Lights glow. But gravity knows something is changing. It always knows. Quantum sensors do not interpret gravity emotionally. They do not decide whether change is dangerous or safe. They simply measure. They offer data, clean and quiet, like a mirror held up to the planet. This mirror reflects more than just danger. It reflects the structure of the Earth itself. Caverns, aquifers, dense rock bodies, and faults all shape gravity uniquely. By reading these shapes, scientists learn not just when the Earth might move, but how it is built. Listening becomes understanding. You think about how gravity also connects everything. The same force that keeps the moon in orbit allows atoms to sense underground mass. The same rule applies everywhere, from galaxies to grains of sand. There is comfort in that consistency. Nothing is arbitrary. As you breathe, you imagine gravity holding your thoughts gently in place. You are not floating away. You are supported. The planet carries you even as it shifts and adjusts beneath its surface. This perspective makes Earth feel less threatening and more alive. Like a body stretching after holding tension too long. Like muscles adjusting before a release. Quantum sensing does not prevent movement. It respects it. It acknowledges that the Earth must change. But it offers the possibility of awareness, of earlier understanding, of time to prepare emotionally and physically. Gravity's fingerprints are not warnings shouted in red. They are notes written in pencil, faint but legible if you know how to read them. You imagine future landscapes quietly monitored, not by invasive machines, but by small, patient instruments that simply watch gravity breathe. Hillsides listening, valleys paying attention, the planet observed without being disturbed. This vision feels calm, balanced, cooperative. Science here is not at odds with nature. It aligns itself with natural laws and waits for them to speak. Gravity speaks constantly. It never stops. It does not get tired of being consistent. As the chapter settles, you feel gravity more clearly. Not as heaviness, but as presence. A reminder that you are part of the planet's story, not separate from it. Somewhere below, mass continues to shift. Gravity continues to adjust. Atoms continue to notice. And as your thoughts slow, another image begins to form gently in your mind. If gravity can guide atoms so faithfully as they fall, you begin to wonder what happens when scientists teach atoms to fall together, in perfect listening silence. You imagine letting go, not falling suddenly, not tumbling, but being released into space where nothing resists you. No air, no friction, no interruption, just a quiet surrender to gravity. This is how atoms are taught to fall together, not as individuals, but as companions sharing the same moment. In this controlled stillness, falling becomes a form of listening. Atoms, when released in pairs or clouds, do not simply drop. They trace gravity's shape. They follow its curves with absolute obedience. If gravity were perfectly uniform, every atom would fall in perfect agreement, never drifting apart. But gravity is never perfectly uniform. Carries texture, carries memory. By watching how atoms separate as they fall, scientists learn what gravity is doing beneath them. You picture two atoms starting side by side. They begin their descent together, synchronized like dancers stepping off a stage. At first, they move as one. But slowly, gently, almost imperceptibly, their paths begin to diverge. One feels a slightly stronger pull, the other slightly weaker. The difference is tiny, but it grows with time. This separation is not error. It is information. The process is called atom interferometry, but the name feels heavy compared to the experience itself. What truly happens is simpler. Atoms fall, split into overlapping waves, and then reunite. When they reunite, the difference in their journeys reveals itself as a pattern. A quiet interference. A message written in phase and distance. You do not need to imagine equations. You imagine listening to footsteps in snow. Two people start together, walk the same path, but encounter slightly different terrain. When they meet again, their stories are not identical. The differences tell you something about the ground they crossed. Atoms do the same thing, but with gravity. This technique is powerful because falling amplifies sensitivity. Gravity acts continuously. The longer the atoms fall, the more clearly they reveal the shape of the force guiding them. Even tiny variations become measurable over time. You realize how patient this method is. Nothing is rushed. No sudden force is applied. The atoms are allowed to behave naturally. Science steps back and observes. This patience feels aligned with the Earth itself. Before earthquakes, stress does not scream. It stretches. It accumulates slowly, altering density and mass distribution underground. These changes slightly reshape gravity's slope. Atoms falling above these regions feel the change immediately, even though nothing has moved yet. You rest with this idea. The ground below may be clearing its throat long before it speaks loudly. And atoms are sensitive enough to hear the first hint. In laboratories, scientists cool atoms until their motion nearly stops. Laser light holds them gently, like hands guiding without gripping. When released, the atoms fall freely, untouched by vibration or noise. The environment is engineered for silence. This silence is not emptiness. It is clarity. When atoms fall in silence, gravity's voice becomes unmistakable. The slightest variation leaves a trace. The Earth cannot help but reveal itself. You begin to feel how different this is from traditional sensing. Seismometers wait for shaking. Atom interferometers wait for leaning. One listens for noise. The other listens for intention. Both are valuable, but one speaks earlier. You imagine a region of Earth where stress is building. Rock compresses. Fluids shift. Density increases ever so slightly. Gravity responds. The change is too small to feel, too smooth to shake anything. But falling atoms notice. They separate just a bit more than expected. Their interference pattern shifts. A quiet alert forms, not as a warning siren, but as a deviation from calm. This deviation does not say when the earthquake will happen. It does not claim certainty. It simply says something is changing. And that is enough to matter. You breathe slowly as this sinks in. The future does not need to be known perfectly to be approached gently. Awareness alone can soften fear. Preparation can replace panic. Teaching atoms to fall together is, in a way, teaching humans to trust subtlety. It requires believing that important information does not always announce itself dramatically. That some of the most meaningful signals are quiet and require patience to interpret. Atoms are well suited to this role. They are impartial. They do not exaggerate. They respond exactly as physics demands. Their honesty is absolute. You imagine these falling atoms as messengers traveling between the deep earth and the surface. They do not carry words, only patterns. But patterns are enough. As atoms fall and reunite, Their differences are read like a gentle fingerprint. Scientists compare these fingerprints over time. Slowly, trends emerge. Gravity leans this way. Density shifts that way. Stress builds here. Maps begin to form not of motion, but of preparation. You find this comforting. Earthquakes no longer feel like ambushes. They feel like decisions the planet reaches after long deliberation. Decisions that leave evidence. The falling atoms do not judge these decisions. They simply record the process. You also notice how much trust this approach places in the universe. It assumes that physical laws are stable, that atoms behave consistently, that gravity remains honest. These assumptions have held true across every experiment ever performed. There is peace in that reliability. As you imagine atoms falling in perfect silence, you feel your own body relax. Gravity holds you just as faithfully. You are falling too, in a sense, through time towards sleep. Nothing pushes. Nothing pulls too hard. The metaphor deepens. Just as atoms reveal hidden changes by falling together, your thoughts reveal hidden tensions as they slow. When noise fades, truth surfaces. Science and rest begin to mirror each other. You realize that teaching atoms to fall together is not about control. It is about alignment. Aligning human curiosity with natural behavior. Letting atoms do what they do best and listening carefully. This alignment makes the technology feel less intrusive. It is not forcing Earth to confess. It is noticing what Earth is already sharing. The atoms continue their descent, again and again, patient repetitions building clarity. Each fall adds a layer of understanding. Each comparison refines the picture. And somewhere underground, stress continues to accumulate, slow and silent. The planet prepares itself in ways you cannot see, but atoms can feel. As the chapter settles toward its end, the image of falling atoms lingers gently. Snowflakes in vacuum, messengers in silence, listeners without ears. You sense that something important is building, not just in the earth, but in understanding itself. And as sleep approaches, a new thought begins to form softly. If atoms can reveal the quiet buildup beneath the surface, what does that buildup actually feel like inside the earth, in the long moments before rock finally breaks? You settle into a slower understanding now. One that asks you to let go of suddenness. Earthquakes, you realize, are not surprises to the planet itself. They are not abrupt decisions. They are conclusions reached after long, patient buildup. The ground does not betray itself. It prepares. Deep beneath you, far below soil and roots and water, enormous slabs of rock press against one another. They do not crash. They lean. They push slowly, steadily, with the calm persistence of time itself. Nothing dramatic happens at first. Nothing visible. The surface gives no sign. Stress here behaves like a memory. Rocks remember every tiny movement. Each grain presses against its neighbors. Each crystal lattice stretches just a little. Over years, decades, centuries, this pressure accumulates. The rocks bend, not because they want to break, but because they must accommodate motion they cannot avoid. You imagine holding a stick between your hands and slowly bending it. At first, it yields easily. It flexes. The fibers inside adjust. You feel resistance growing, but nothing snaps. You could hold it there for a long time, balanced between motion and stillness. This is where the Earth lives most of its life, in that long, quiet balance. For most of the build-up before an earthquake, nothing feels urgent. The planet is patient. Stress migrates through rock like warmth through a wall. Slowly, inevitably, invisibly. There is no single moment when danger appears. There is only accumulation. You rest with this idea, and fear loosens its grip. Because buildup is not chaos. It is structured, governed by physical laws, measurable if you know how to listen. Rocks under stress change in subtle ways. Their density shifts. Microscopic cracks open and close. Fluids move through tiny pores. Heat redistributes. All of this happens long before anything breaks. These changes are not loud. They do not shake the surface. But they alter the Earth's internal balance. And that balance speaks through gravity, through time, through the motion of atoms. Quantum sensors are not waiting for the break. They are waiting for the buildup. You imagine them as patient companions, sitting quietly while stress accumulates deep below. They do not demand action. They simply watch. They record. They notice trends. This patience feels deeply aligned with sleep. You know how your own body prepares for rest. Muscles release tension gradually. Breathing slows before you notice it. Consciousness softens in stages. Sleep does not arrive suddenly. It builds. The earth sleeps and wakes on its own cycles too. Before rock fails, it resists. The resistance grows stronger as stress increases. This resistance changes how seismic waves travel, how gravity behaves, how atoms fall. The planet becomes slightly stiffer, slightly heavier in places, slightly more uneven. These are whispers, not alarms. You imagine the Earth as a giant instrument being slowly tuned. Strings tighten. Frequencies shift. Nothing is played yet, but the preparation is audible if you know the sound of silence. Traditional earthquake science has always known about this buildup, but measuring it has been difficult. The changes are spread over large areas and long timescales. They are masked by noise, weather, human activity, the restless surface of daily life. Quantum sensing offers a new way to approach this problem. It does not try to isolate one signal and ignore the rest. It embraces sensitivity so high that even averaged, distributed changes become visible. You rest with the idea that earthquakes are not points in time. They are processes, long stories that end with a sharp sentence. Understanding the story matters. When stress builds, the earth becomes more organized in a way. Forces align. Energy concentrates. This organization is temporary and unstable, but it is real. The planet enters a state of tension that can be sensed if you watch carefully. Atoms are especially good at watching carefully. They do not get bored during long waits. They do not lose focus. They respond the same way today as they did yesterday. Their patience matches the planet's patience. You imagine quantum sensors noticing slight trends. Gravity changing here, stabilizing there. Atomic clocks drifting just a fraction relative to one another. Falling atoms separating a bit more than before. Individually, these signals mean little. Together, over time, they tell a story of buildup. This story does not promise certainty. It does not say exactly when the break will happen. But it changes the emotional landscape. It replaces suddenness with anticipation. Shock with awareness. You breathe slowly as this understanding settles. Fear thrives on unpredictability. Awareness softens it. The earth does not intend harm. It follows physics. Stress accumulates because plates move. Plates move because the planet cools and reshapes itself. Earthquakes are expressions of a living planet adjusting its posture. Seeing this does not make earthquakes harmless, but it makes them understandable. Quantum sensors, in their quiet waiting, represent a shift in how humans relate to natural danger. Instead of reacting only after disaster, they encourage earlier engagement. They invite preparation rather than panic. You imagine communities where subtle warnings allow small adjustments. Trains slowing, systems checking themselves, people receiving notice, not commands. Time, even seconds, offered as a gift rather than seized in fear. All of this begins with recognizing buildup. The quiet before the break is not empty. It is full of information. It is dense with meaning. It is simply spread thin across time and space. Atoms help gather it. You notice how gentle this approach feels. It does not demand perfection. It does not promise control. It offers awareness, which is something humans can carry without breaking. As your thoughts slow, you feel the analogy deepen. Just as rocks bend long before they snap, minds hold tension before releasing it. Sleep comes more easily when you notice the buildup and allow release rather than resisting it. The Earth, too, releases when it must. Quantum sensors do not prevent that release. They honor it by paying attention beforehand. As the chapter nears its close, the image of buildup lingers. Layers of rock leaning into one another. Stress migrating silently. Gravity adjusting. Atoms noticing. The planet is not quiet because nothing is happening. It is quiet because preparation takes time. And as you drift closer to sleep, a final curiosity rises gently. If this buildup leaves such subtle signs, you begin to wonder, how deeply into the earth can we really see when we learn to listen beneath our feet? You begin this chapter by looking downward, not with your eyes, but with your imagination. Beneath your feet, the ground feels solid, dependable, finished. It holds your weight without question. But you know now that this solidity is only the surface of a much deeper story. The earth is layered, not just in rock, but in time. Soil rests on sediment. Sediment presses on stone. Stone gives way to denser rock, and deeper still, heat and pressure blur boundaries until matter itself behaves differently. Each layer carries memory. Every crack, every fold, every fault is a record of forces that once passed through. You imagine these layers stacked like chapters in a very old book. Some pages are thin and fragile. Others are thick and resistant. Together, they tell a story that is still being written. Fault lines are not clean breaks. They are zones of negotiation. Broad regions where rock stretches, compresses, and slides by fractions so small they escape notice. These zones can be kilometers wide and hundreds of kilometers long. They are not scars so much as seams, places where the planet adjusts its shape. Most of the time, these adjustments are gentle. Rock creeps. Stress redistributes. Energy flows without violence. The Earth prefers gradual solutions when it can find them. But sometimes resistance builds. To see this buildup, you must look beneath the obvious. Surface measurements tell only part of the story. The real action happens far below, where pressure reshapes matter quietly and continuously. This is where quantum sensing begins to feel almost like vision. Not vision of color or shape, but vision of influence, of strain, of imbalance. Quantum measurements do not see rock directly. They see effects. They notice how gravity curves, how time shifts, how falling atoms separate differently in one place than another. From these clues an image forms. You imagine a map slowly appearing in the mind. Not a sharp map with borders and labels, but a soft one. Areas of higher stress glow faintly. Regions of relaxation dim. The picture changes over weeks, months, years. This map is not drawn once. It is redrawn constantly. You rest with this idea. Seeing here is not a moment. It is a process. Understanding arrives gradually. The way dawn replaces night without a clear dividing line. Traditional geology has always tried to see beneath the surface. Seismic waves, drilling, and modeling have revealed much. But these methods often rely on events or disturbances. They listen after the Earth speaks loudly. Quantum sensing listens while the Earth is still whispering. This allows something new. Not certainty but context. You imagine standing on a quiet hillside. Nothing moves. Nothing shakes. But beneath you, stress is migrating slowly along a fault. Gravity is adjusting. Time is bending ever so slightly. Atoms are responding. Without instruments, this place feels peaceful. With quantum instruments, it feels alive with subtle motion. This does not make the place more dangerous. It makes it more understandable. You realize that danger often comes from ignorance, not from nature itself. When change is invisible, it feels threatening. When change is gradual and observable, it becomes something you can live alongside. Quantum maps of stress do not point to a single future. They show tendencies, directions, probabilities. They reveal where energy is concentrating and where it is releasing. This information is gentle. It does not demand panic. It invites respect. You imagine how this changes the human relationship with the ground beneath cities. Instead of assuming stability until disaster strikes, people may learn to live with a more nuanced understanding. To accept that the earth is always adjusting, always balancing. This acceptance feels calming. The unseen beneath your feet is not chaotic. It is structured by physical law. Stress follows paths of least resistance. Energy seeks release where it can find it. These tendencies can be mapped, slowly, patiently. Quantum sensing does not replace intuition. It refines it. You think about how your own body gives subtle signals before strain becomes injury. Tightness, a slight ache, A change in posture. If you listen early, you can adjust. If you ignore it, pain arrives suddenly. The Earth behaves the same way. Fault zones signal discomfort long before rupture. Microcracks open and close. Fluids migrate. Density changes. These are not random events. They are part of the planet's feedback system. Quantum instruments translate this feedback into something humans can interpret. You imagine stress maps updating quietly over time. No flashing lights. No alarms. Just trends, curves, gradients. These maps do not remove uncertainty. Earthquakes will always retain some unpredictability. But uncertainty does not mean blindness. There is a wide space between knowing nothing and knowing everything. Quantum sensing lives in that space. You feel a sense of humility here. Seeing the unseen does not mean mastering it. It means acknowledging how much has always been happening without your awareness. It invites gentler decisions, slower planning, deeper respect. You imagine engineers using these maps not to stop earthquakes, but to design structures that coexist with stress. To build with awareness rather than assumption. To place critical systems where stress accumulates least. This feels like cooperation rather than control. As your breathing deepens, the layers beneath you feel less threatening and more familiar. They are not hiding something from you. They are simply deep, and depth takes time to understand. Quantum sensing shortens that time just a little. Enough to matter. You also notice how quiet this form of seeing is. No explosions. No drilling. No disturbance. The Earth is observed without being touched. It continues its slow movements uninterrupted. There is kindness in that. Science, at its best, does not demand confession. It listens for consent. Gravity consents. Time consents. Atoms consent. They share their behavior freely. You imagine the unseen beneath your feet as a living archive, constantly updating itself. Quantum sensors read this archive without erasing it. They leave no marks, only understanding. As the chapter settles, you feel the unseen becoming less mysterious. Not fully known, but approachable. The darkness beneath the surface is not empty. It is full of structure, history, and gentle motion. And as sleep draws closer, a final question forms softly. If we can begin to see the unseen beneath our feet, how might this quiet knowledge travel beyond laboratories, into the open world where people live their everyday lives? You imagine a door opening softly. Behind it is a laboratory, clean, controlled, humming with electricity and intention. White walls, laser light, carefully cooled atoms held in place by precision and patience. For a long time, this has been the home of quantum sensing. A protected space where silence is engineered and every vibration accounted for. But science does not stay indoors forever. Slowly, carefully, these delicate instruments begin a journey outward. Not rushed, not dramatic. They leave the laboratory the way a thought leaves the mind and enters the world. Tentatively, curious, adaptable. You follow them as they travel. The challenge is not curiosity. It is noise. The natural world is full of motion. Wind moves trees. Water shifts underground. Animals pass. Humans build and travel. All of this creates vibration, temperature change, and electromagnetic chatter. To listen to gravity and time, instruments must learn how to live quietly within all this life. This is where technology begins to learn stillness. Quantum sensors are redesigned not to dominate their surroundings, but to blend into them. They are buried gently underground, shielded from surface disturbances. They are placed in tunnels, old mines, and quiet valleys. Sometimes they are wrapped in layers of Earth itself, using the planet as protection. You imagine one of these sensors resting beneath a hillside. Above it, grass moves in the wind. Clouds pass. Seasons change. Below it, atoms fall in silence, counting time, listening to gravity's shape. The instrument does nothing visible. It does not announce its presence. It simply listens. This transition from laboratory to landscape is more than engineering. It is philosophical. It requires accepting that control will never be perfect, that nature will always add its own rhythms. The goal is not to eliminate these rhythms, but to understand them well enough to listen through them. You rest with this idea. Listening does not mean silence. It means discernment. Quantum sensors in the field must learn the difference between surface noise and deep signals. They must recognize the signature of passing trucks and ignore it. They must notice temperature changes and compensate. They must learn the daily breathing of the atmosphere so they can hear the slower breathing of the earth. This learning takes time, takes patience, takes humility. You imagine scientists visiting these quiet installations. They walk carefully. They speak softly. They check systems designed to run for months or years without interruption. The sensors do not need constant attention. Like the atoms they rely on, they are content to wait. Over time, something beautiful begins to happen. The data collected from these quiet hillsides and valleys begins to match what was seen in the lab. Gravity shifts are recorded. Atomic clocks drift relative to one another. Falling atoms reveal subtle changes in the ground beneath. The Earth is speaking the same language everywhere. This realization feels comforting. It means the universe is consistent. It means that the careful listening learned indoors can be trusted outdoors too. You imagine a network forming slowly, not a grid of machines, but a constellation of listeners, each one tuned to its location, each one contributing a piece of a larger picture. Mountains host sensors that feel the weight of rock adjusting. Valleys listen for fluid movement underground. Coastal regions notice the subtle pull of tides interacting with tectonic stress. Each place adds its own voice. Together, they form a chorus, not loud, not urgent, but aware. You think about how different this is from traditional monitoring. There are no dramatic towers, no flashing lights, no sense of surveillance. These instruments do not watch people. They watch physics. This distinction matters. Technology often feels intrusive because it focuses on control and prediction. Quantum sensing, in this context, feels more like companionship. It sits quietly alongside the planet, observing without interference. You rest with the idea that landscapes themselves become part of the sensing system. Hillsides shield noise. Rock layers stabilize temperature. Distance from cities creates natural quiet. Nature helps science listen. This partnership feels balanced. As sensors settle into place, time becomes their ally. Long-term observation reveals patterns that short experiments cannot. Seasonal cycles appear. Weather-related signals are cataloged and understood. Slowly, the deeper signals stand out more clearly. Patience sharpens perception. You imagine years passing. The sensors continue their work through winters and summers, through calm periods and distant earthquakes. They collect a continuous story of gravity and time. Within that story, subtle changes begin to matter more. A slight trend in one region, a gentle shift across several sensors, a pattern emerging slowly, like an image developing in old photographic film. No single sensor carries certainty, but together they build context. You feel how calming this distributed listening is. There is no pressure on one instrument to be perfect. Understanding emerges from relationships, from comparison, from shared observation. This mirrors something deeply human. You understand the world better when you listen from many perspectives, when you compare notes, when you allow time for patterns to reveal themselves. Quantum sensing in the field embodies this wisdom. As your breathing slows, you imagine landscapes quietly aware of themselves. Not conscious in a human way, but responsive. Gravity felt. Time measured. Stress noted. This awareness does not stop earthquakes, but it changes how humans relate to them. It replaces surprise with familiarity, shock with continuity. The Earth does not become safer. It becomes better understood. And understanding is a form of comfort. You imagine future generations growing up knowing that the ground beneath them is always being listened to, not watched with fear, but accompanied with care. That subtle changes are noticed early. That science is present not as authority, but as awareness. This vision feels gentle, reassuring. The chapter begins to settle now. The journey from laboratory to hillside feels complete, but the story continues. Instruments listen quietly. Landscapes hold them. Atoms fall. Time ticks, and as sleep draws closer, another thought drifts into your awareness. If these quiet listeners can offer early hints of change, how might even a few seconds of notice reshape the way humans experience time itself? You begin this chapter by slowing your sense of time, not counting minutes or hours, but feeling the weight of a single second. One quiet heartbeat, one breath drawn fully in, one small pause where awareness has room to arrive. A few seconds rarely seem important until they are. In everyday life, time flows gently forward, unnoticed. You move through it without measuring each moment. But when something sudden happens, time sharpens. It stretches or collapses. Seconds become precious. They decide outcomes. Earthquakes have always belonged to this sudden category. They arrive without warning, turning ordinary moments into before and after markers. Human time in those moments feels helpless. There is no pause, no preparation, only reaction. Quantum sensing gently alters this relationship, not by promising certainty, not by predicting exact moments, but by offering something subtler and more humane. Notice. Notice changes how time feels. A few seconds of warning may not sound like much, but in human experience they are enormous. They are the difference between standing and bracing, between moving away from danger and being caught unaware, between panic and action. You imagine hearing a soft signal, not loud, not urgent, just clear. A message that says something is beginning. Not that disaster is guaranteed, but that the planet is shifting into a new phase. That message does not shout. It arrives quietly, giving you space to respond. This is the kind of time quantum sensors offer. Not extended foresight, but early awareness. A small opening in the flow of events where choice becomes possible. You rest with this idea. Time here is not lengthened. It is softened. Traditional earthquake warnings rely on detecting seismic waves after rock has already broken. These systems can offer seconds of warning, but only once the event is underway. Quantum sensing aims earlier. It listens for preparation, not release. This distinction matters emotionally. Knowing something is building feels different from knowing something has already begun. One invites readiness. The other triggers alarm. Quantum sensors do not eliminate danger. They reshape anticipation. You imagine a future where subtle signals are integrated gently into daily life. Infrastructure systems adjust quietly. Elevators pause. Trains slow. Power grids shift into safe modes. People receive calm notifications, not alarms. There is no chaos, just adjustment. This vision is not about dramatic heroics. It is about ordinary moments being protected, about giving human nervous systems a chance to respond thoughtfully rather than reflexively. You think about how your own body values early signals. Hunger arrives before exhaustion, thirst before dehydration, pain before injury becomes severe. These signals do not guarantee harm. They offer guidance. Earth's early signals can serve the same role. Quantum sensors provide data that can be interpreted probabilistically. Not yes or no, not now or never, but likelihoods, trends, gradients of change. This language is softer, but more honest. You realize how important honesty is when dealing with fear. Overpromising certainty breeds distrust. Silence breeds panic. Gentle notice builds resilience. Human time is not just measured in seconds. It is measured in how those seconds feel, whether they are filled with shock or with preparation. Quantum sensing aims to change the feeling of time around earthquakes, to make it less sudden, less cruel, less disorienting. You imagine communities where this awareness becomes part of cultural understanding. People know that the ground is always being listened to, that early signs are part of a long story, that earthquakes are processes, not ambushes. This knowledge does not create complacency, creates respect. You breathe slowly as this settles. The idea that technology can serve emotional as well as physical safety feels deeply reassuring. Science here is not cold or distant. It is attentive. Time itself becomes a collaborator. Atomic clocks measure tiny shifts in time caused by gravity changes. Atom interferometers reveal slow trends in motion. Together, These signals create timelines of buildup. From those timelines, early warnings can emerge. Not perfect, not universal, but meaningful. You think about how even a few seconds can ripple outward. Emergency systems can trigger automatically. Children can be guided to safer positions. Surgeons can pause delicate procedures. These moments matter. And beyond immediate safety, early notice changes memory. People remember being warned, not blindsided. They remember preparation, not just impact. This shapes collective experience. You realize that disasters are not only physical events. They are psychological ones. Suddenness amplifies trauma. Awareness softens it. Quantum sensing cannot prevent earthquakes, but it can reduce the shock they deliver to human systems, both mechanical and emotional. You rest with this balance. Technology that respects limits, that offers help without promising control. Human time in this vision is not stretched endlessly. It is honored. You imagine how this awareness might spread gradually, not through fear-based messaging, but through trust, through consistent, quiet reliability. Systems that work when needed and fade into the background when not. This is a very different relationship with technology than constant alerts and interruptions. It is closer to companionship than command. As your thoughts slow, you notice how your own sense of time softens. The future feels less abrupt, less like a cliff, more like a slope. This feeling is perhaps the most important outcome of early warning. Not just safety, but psychological ease. The planet becomes something you live with, not something that ambushes you. Quantum sensing opens a small window into the future, not to control it, but to meet it gently. The chapter begins to quiet now. Seconds stretch. Breaths deepen. Awareness settles into rest. Somewhere, atoms continue to tick. Gravity continues to shift. Sensors continue to listen. And as you drift closer to sleep, one last reflection forms quietly. If the planet can be heard, and time can be softened, what kind of relationship might humans finally build with the Earth itself? You arrive now at the edge of understanding, where observation and imagination meet. You picture the Earth as a living, breathing entity, not in a mystical sense, but in the practical, elegant language of physics. It speaks constantly, if only we learn how to listen. Gravity murmurs. Atomic waves ripple. Stress pulses quietly through rock. The signals are subtle but persistent. The planet has never been silent. You realize that what you have been exploring in earlier chapters is part of a single story. Earth communicates. It does not shout. It does not demand. It simply conveys, through the mechanisms of physics, what is happening beneath the surface. And now, for the first time, humanity has developed the tools to hear it. Quantum sensors have become intermediaries. They translate imperceptible changes into readable patterns, converting the whispers of falling atoms and subtle gravitational shifts into data humans can interpret. These instruments do not invent messages. They reveal what is already there. They are translators, connecting deep rock with conscious awareness. You imagine a field of these sensors, arrayed across hillsides and valleys. Each one is patient, precise, quiet. Together, they create a network that hums with awareness. Not audible to the ear, not visible to the eye, but present in a way that changes the human relationship with the Earth. With every measurement, the planet becomes slightly more knowable. With every observation, fear transforms into curiosity, and anticipation becomes possible. The process is delicate, like tending a garden. Attention is steady but gentle. Interference is minimized. The natural world is not commanded. It is acknowledged, and in this acknowledgement there is care. Listening itself becomes an act of respect. You consider the atoms, those tiny oscillators, that have been at the heart of this story. Alone they are small. Their waves are imperceptible. Yet when guided, cooled, isolated, and observed, they convey the movements of mountains, the buildup of stress, and the subtle contours of underground mass. They have become messengers. They carry information from regions humans cannot reach, translating the quiet language of rock and gravity into a form we can comprehend. This insight changes perception. Earthquakes, once feared as sudden calamities, now appear differently. They are not capricious acts of destruction. They are the natural outcome of processes that have long been in motion. Stress accumulates, rocks bend, gravity shifts, and atoms respond, all before anything breaks. The future is not hidden. It is signaled in soft ways. Humans have finely tuned instruments to recognize those signals. You rest with this awareness. The planet is patient. The Earth does not rush. It does not withhold information out of malice. It simply operates according to consistent, immutable laws. Those laws, once opaque, are now partially audible through the voices of quantum sensors. The universe speaks, and humans are beginning to understand. You reflect on the broader implications. Science, when approached this way, becomes a form of dialogue rather than domination. Observing the Earth is not a conquest. It is a conversation, conducted through careful listening and respectful measurement. The act of listening becomes a form of care. By paying attention, humans participate in the planet's story without harming it. This perspective is deeply soothing. You realize that knowledge need not be frantic or urgent. Understanding the Earth's subtle cues is not about controlling outcomes. It is about cultivating awareness. Being attuned to natural rhythms allows action informed by context, rather than reaction driven by surprise. In this attunement, fear softens, replaced by thoughtful attention. You imagine the way early warnings, generated from quantum measurements, ripple outward, not as alarms that scream and startle, but as gentle signals. A few seconds, perhaps, but enough for a pause, enough to step aside, to brace, to prepare. That pause is a gift. Awareness itself is a form of care, both for human life and for the planet. Listening changes the relationship between observer and observed. In this quiet, meditative state, you consider the Earth not just as a provider of warnings, but as a living archive. Layers of rock, tectonic plates, and subterranean fluids all record history. Each seismic shift, each movement of mass, leaves traces. Quantum sensing allows us to read these traces with fidelity that was previously unimaginable. The planet has always been communicating. Only now do we have ears capable of hearing. You drift further into this vision. Mountains, forests, and oceans are not just scenery. They are active participants in this conversation. Hillsides guide instruments into protected positions. Valleys channel subtle shifts. Ocean tides add rhythm. Every feature of the landscape contributes to the symphony of motion, and quantum instruments are the attentive audience. Nature and technology collaborate seamlessly. The story expands beyond instruments alone. You imagine networks of sensors stretching across continents, collecting data, creating maps of stress and movement. These maps are dynamic, living representations of the planet's internal state. They glow faintly in the mind's eye, showing zones of higher tension, corridors of fluid movement, subtle variations in gravitational pull. Each reading contributes a note to the melody of Earth's ongoing narrative. Even as sleep approaches, this understanding resonates. The Earth's language is not sudden. It is continuous. Patterns emerge slowly, over days, months, years. The planet's patience mirrors the patience required to listen and interpret. Knowledge grows incrementally, quietly, persistently. You reflect on human time in relation to this planetary rhythm. Where seconds can make a difference in crisis, years make a difference in comprehension. Both scales are respected in this dialogue. Early warnings offer seconds. Quantum mapping offers decades of understanding. And throughout, the voice of the Earth remains consistent, steady, predictable within the scope of its own rules. There is comfort in the consistency. Knowing that the planet operates according to patterns that can be learned and understood provides a gentle sense of order in a universe that can sometimes feel chaotic. The act of listening itself becomes a form of alignment, aligning human perception with natural processes, aligning awareness with the flow of time and matter. You think of the atoms once more. Each one, a tiny oscillator, has become part of this bridge between deep geological processes and conscious human understanding. Their behavior, wave-like, probabilistic, delicate, illustrates a principle that now feels personal. The smallest things can reveal the largest truths. Even whispers carry messages. And you begin to feel how deeply poetic this is. The same softness, the same uncertainty, that once felt strange or intimidating, is now the key to understanding. The world's subtlety is not a barrier. It is an invitation to engage attentively. Listening becomes a gentle art, one that respects complexity while offering clarity. You rest in this image. Earth communicating, humans listening, instruments translating whispers, and atoms bridging the invisible. All of it occurs without force, without drama, without hurry. The planet continues its slow adjustments, shifting plates, migrating stress, altering gravity. And humans, through careful observation, respond not with panic but with understanding. The story draws together threads from the journey you have imagined. Atomic clocks measuring precise time, falling atoms revealing gradients of gravity, layers of rock interpreted through quantum sensors, early warnings providing brief but meaningful notice. Everything converges toward a vision of coexistence and respect. Fear is replaced with mindfulness. Surprise is replaced with attentive awareness. Uncertainty becomes something to observe rather than something to dread. As you drift closer to sleep, you notice how naturally this rhythm aligns with your own. Thoughts slow. Breathing deepens. Awareness softens. You begin to inhabit the same patience that the earth exhibits. You carry the sense that everything is connected. The unseen movements below your feet, the oscillations of atoms, the steady pull of gravity, the gentle ticking of time. In these final moments, you feel the power of listening. Not just the act of collecting data or interpreting signals, but the emotional, meditative resonance of attention itself. The planet communicates, the instruments translate, and you, as a human observer, rest in the understanding that awareness is a form of care, for yourself, for your surroundings, and for the earth itself. Sleep approaches, slow and certain. The quantum waves continue, the atoms continue to fall, gravity continues to shift, and the planet continues speaking. Its voice is not loud or urgent, but persistent, consistent, patient. And you, resting with the knowledge of its whispers, feel a deep sense of belonging in a world that has always been communicating. The journey is complete for now. You have listened, imagined, understood. And yet, the Earth's narrative continues beyond your conscious attention. The story does not end with your sleep. It goes on endlessly, softly, always. And as you close your eyes, one final thought drifts into consciousness, gentle and unresolved. Even as you sleep, the planet speaks, and perhaps in its quiet way, it is waiting for you to hear again tomorrow.